Hello all, I welcome you all for this lecture series 5 in testing of materials in the course engineering materials. So today we are going to discuss about a very interesting test which is we usually you give a demo with a fun in the class. So we call upon a student and catch hold of his hand and we start twisting it and the boy makes a sound because of twisting force. Yes, now I now understand that you all come to know what we are going to discuss. It's all about the torsion tests. Okay, so torsion test is a mechanical test used to determine the behavior of a material under torsion or twisting force. So it assesses the material's ability to withstand torsional loading and provides information about its mechanical properties such as shear modulus, shear strength, and ductility. So let us have a look at the setup of torsion test where there is a motor to drive this round rod. So usually this torque is defined as the twisting force which is applied equal in magnitude across the tangents of the circle obtained at the cross section of the bar. So basically why we need to test torsion. So when you consider this propeller shaft in any automobile, you could have seen a propeller shaft that is being transmitting power from the engine to the wheel. There exists a twisting force where it has to drive the energy from engine that is being transferred to the wheels. The wheels have load upon which it is to be carried out. So we have to find out the ability of the material to withstand twisting force without deformation. It should twist, transmit all the energies from the engine to the wheel through, we call it as universal joint, right? Yes. So we will look into the testing procedure of this torsion test. So specimen preparation happens, a cylindrical or prismatic specimen of a specific length and diameter is prepared from the material of interest. The ends of the specimen are typically machined to have flat and parallel surfaces to ensure proper gripping during the tests. The test is performed using a torsion testing machine, also known as torsion tester. The machine consists of a drive system, grips, and a fixture to hold the specimen and a torque measuring system. The specimen mounting is securely mounted between the grips or fixture of the torsion testing machine. One end of the specimen is held stationary when the other end is attached to a drive system. So application of torque happens with the twisting force or torque that is to be applied at the free end of the specimen, causing it to twist and rotate about its longitudinal axis. The torque is applied gradually and continuously until specimen fractures. The releases reaches a specified deformation. So torque measurement during the test, the machine measures and records the applied torque. The torque measuring system is typically based on strain gauges or strain sensitivity element which detects the deformation or strain caused by the applied torque. So angular deformation measurement of twisting angle of the specimen is measured as the test progresses. This measurement is typically done using a dial gauge or an optical device. So finally, there comes plotting the torque versus twisting angle curve. This recorded torque and corresponding twisting angle data are used to plot a torque versus twisting angle curve. The curve provides information about the material's response to the torsional loading including its elastic behavior, yield point, ultimate tensile strength, and ductility. So calculation of mechanical properties, the torsion test results can be used to calculate various mechanical properties that are shear modulus, shear strength of the material. These calculations are based on the geometry of the specimen, recorded torque, and twist angle data. So the torsion test is commonly used in material science, engineering, and manufacturing industries to evaluate the torsional strength and behavior of the materials. It helps in designing and selecting materials for applications involving twisting or rotational forces such as shafts, gears, springs, and structural components subjected to torsional loads, right? So here we have a formula tau by r equal to t by j equal to g theta by l, where j is the polar moment and tau is the shear stress that is happening in the rod, and r is the radius, and g is the modulus of rigidity, theta is the angle of twist. That is before twist it is 0, and after twist that there will be some angle, and length L, the total length of the rod. So here the green picture shows how this torque is applied in the opposite direction. It rotates, one rotates in clockwise, the other one is fixed, so that it is actually rotating in anti-clockwise with respect to the rotating member. So we have a shear stress distribution diagram here, where the external torque is applied here and there is an internal torque which is a fixed side, and the shear stress is happening here in this area. So the angle of twist is measured from initial point to the final point of the torque, and when it is released the material regains its original position, so that we can use this for drive systems. Okay, so this is all about torsion test which is being tested. So I hope you would have understand the torsion test, and I thank everyone for being patient to listening this lecture. So save trees, save nature. Thank you.